This is our 7th lecture on topic trigonometric functions, and we are learning the second part of this topic, that is the solution of triangle. And in this second part, we have learned sine rule and cosine rule in our previous lectures. Now in this lecture, we will learn the third important rule, that is projection rule. Projection rule. Before starting this rule, let me clear the meaning of projection of a segment. What is meant by projection? In vector also we have learned this concept of projection. Let us see the meaning of projection about triangle here. Here we have three types of triangle. Suppose the triangle is acute angle triangle like this. If ABC is a triangle, then what is the projection of side AB on side BC? That we must know. Projection of side, suppose here AB on side BC. Also there may be question of projection of side AC on side BC, or BC on AB, or AB on AC. That means projection of one side on another. That is the general question here. Okay. For example, let us first find the projection of side AB on side BC. To find the projection of AB on BC, this projection is nothing but, we can say in simple word, as shadow. Nothing but the shadow. So the shadow of this AB on side BC can be obtained by drawing perpendicular on it. If this is B is the foot of the perpendicular, then the projection of side AB on side BC, AB and this is BC. So the shadow of AB on side BC is nothing but this BD. So this will be the projection of AB on BC. Similarly, what is the projection of AC on BC? Means shadow of AC on side BC. It is nothing but the BC. So this is the projection of AC on BC. What is the projection of BC on AB? For that, we have to draw the perpendicular from any one end point of this BC on AC. So here, if you draw perpendicular, then this, suppose third point, that is E. Then the projection of this BC on AC is nothing but the EC. It is EC. The shadow of this BC on side AC, it will be EC. Then projection of AB on AC. To find the projection of AB on AC, what we have to do? We have to draw the perpendicular from this. So that projection is nothing but EA. EA is the projection of side AB on AC. Means the shadow of AB on AC is nothing but EA. So these are the projections of one side on another side of triangle. We have to use this concept to prove this projection rule. Let us see the statement of projection rule first, and we will use that concept of projection of one side on another. In triangle ABC, if you take any one side, then A, then that A is nothing but B cos C plus C cos B. Means if A is to the left, then to the right there are small b and c. Whenever we are taking small b, it is with cosine of angle C, and small c is with cosine of angle B. Similarly, we can write small b is equal to, here is B, so remains C and A, so small c cos A plus small a cos C. And third similar result or projection rule is small c is nothing but, now C is here, remains A and B, so A cos B plus B cos A. These are three forms of projection rule for triangle ABC. Okay, let us try to prove this result. For this, consider triangle ABC. Initially we will prove this first result, and we can say that similarly we can prove this remaining two. To prove this first result A, let us consider that A is the vertex such that it is, suppose, at this position. Then considering triangle, we will consider triangle A, B, C like this, in which angle B is here acute angle. First, actually we are proving this first result, but for this first result we will consider the different positions of angle B. Here in this case the angle B is acute angle. For instance, I will write here B as acute angle. Okay. Then in second case we will consider the angle B as obtuse angle. So the triangle will be like this. Here B is obtuse. In this case the B is obtuse angle. And in third case we will consider B as right angle. A is here, this is B, this is will be as right angle. Okay. Now let us see first case. Before that we will write, let ABC be a triangle then case 1, projection rule, case 1. In this case first, angle B, obviously if this B is acute angle, A is also acute and C is also acute angle. We are proving result for small a, so we will think about angles B and C. Here both B and C are acute angles. Here B is obtuse, C is acute angle. Here B is right angle and C is once again acute angle. So C is always acute angle, but B is acute, obtuse and right. So we will consider those two cases for those angles. Angle B and angle C are acute angles. This is our case first. Okay. This first case we are written in this form. Now, in this case, if you draw perpendicular, or if you draw the altitude passing through point A, then it will cut the side BC at certain point, let it be point D. Okay. Then Can you find here the projection of this AB? Obviously, that projection of AB is nothing but the shadow of AB on side BC. That shadow is nothing but BD. Conventionally, this BC is nothing but small a. This is small a. This is small side opposite to angle B is small b, and side opposite to angle C is small c. So here projection here projection of AB on side BC is equal to, that we have to find it. It is nothing but actual BD. Okay, so let us find this BD. Here angle is B. This is our projection BD. So if you write here cos of angle B, it is nothing but the adjacent side upon hypotenuse. As in triangle ABD, cos B is equal to, what will be cos B? Cos B is nothing but the adjacent upon hypotenuse. So adjacent is BD and hypotenuse will be C, which implies BD is equal to C cos B. So projection of AB on BC is equal to BD. Therefore BD is equal to C cos B. Therefore the projection of AB on BC is equal to C cos B. This is suppose first. Similarly, we can find the projection of AC on side BC. So projection of AC on side BC will be DC. Also, projection of AC on side BC is equal to DC, and it is equal to, similarly, if you consider here angle C, then cos of C is equal to DC upon B. Therefore DC is equal to B cos C. So DC is equal to, in the same way we get B cos C. This is second one. Okay, therefore now what do we have to find? We have to find this result, to this result. So start with A. What is A? A is nothing but this BC. Now A is equal to BC, and this BC is nothing but BD plus DC. So BC is equal to BD plus DC. What is BD now? This BD is nothing but the projection of AB on BC, and that is nothing but C cos B. So BD is equal to C cos B. And what is DC? DC is nothing but the projection of AC on BC, it is B cos C. So A is equal to C cos B plus B cos C. So this is our first result. It can be written as A is equal to B cos C plus C cos B. Okay, so this is first case. Is it clear? It's very simple to prove first result. Now we will prove the same first result for this triangle ABC, in which angle B is obtuse angle triangle. Okay, we will perform the same construction here, that draw perpendicular or altitude through vertex A. It will cut this side BC, in suppose point B1 angle. And in similar way, like first case, let us see case 2.
Projection rule case 2,
in which angle B is obtuse angle. Angle B is obtuse angle and angle C is obviously acute, because if one angle is obtuse angle in triangle, remaining two will be acute angles. So here angle A and angle C are acute angles. In this figure now, if you observe the projection of AB on BC, AB is here, its projection on side BC is nothing but DB. Now instead of BD, we will write here DB. Actually it is same, BD and DB are same. So this DB is equal to, now here this is angle B, so this angle will be pi minus B. Okay, because these two angles are in linear pair, one is B, so remaining angle or its linear angle is pi minus B. So here we get cos B is equal to, cos B means cos of pi minus B, or I will write the total answer once again. So projection of AB on BC is equal to DB. Therefore, in triangle ADB, projection of AB on actual side BC is equal to DB. Okay, in triangle ADB. But here angle B is nothing but pi minus B. Therefore, cos of pi minus B is equal to adjacent side, that is DB, upon hypotenuse is side opposite angle C. This is small b, this is small a. Okay, by combination. So hypotenuse is AB, that is equal to dB upon AB means small c. Therefore dB is equal to, here dB is equal to C cos of pi minus B, and cos of pi minus B, it is minus cos B, because pi minus means second quadrant, in second quadrant cosine ratio is negative, so we get here minus C cos B. Okay, now this is the projection of AB on BC. Now we have to find the projection of, in this case also we have found projection of AB on BC and AC on BC. We will find the same two projections in each case. Here projection of AB on BC we have found. Now find the projection of AC on BC. Now projection of AC on side BC is equal to, now the projection of AC on BC is nothing but the shadow of AC on BC, it is BC. The shadow of this is this much, BC, so it is equal to BC. So what is the projection of AC on BC? It is BC. Therefore, in this triangle now, in triangle ADC, cos of C is equal to cos C is equal to cos C is nothing but the adjacent side is this whole BC upon hypotenuse is AC. So it is nothing but BC upon hypotenuse as AC. Therefore, we get here cos C is equal to BC upon AC is nothing but small b. The length of side AC is small. This gives us BC equal to B cos C. B cos C. This is our suppose here third result, and this one has fourth result, small fourth. Therefore, from these two, now we are known about DB and DC. What we want? We want here the result about small a. Now, therefore, small a is equal to, what is a? Here a is nothing but length of side BC. A is nothing but BC. And as B, BC are collinear, so BC is equal to BC minus DB. So this BC is equal to BC minus DB. So what is BC? BC is B cos C from this fourth minus, what is DB? DB is minus of C minus D. It becomes plus C cos B. So this A is equal to B cos C plus C cos B. So this is equal to A, or you can write A is equal to this. So this is the second way to obtain the same first result A. Okay, and this is about the obtuse angle B. Now let us see about right angle B.
Projection rule case 3.
In this case, what happened? Side AC is B, here is also AC B, this is A and this is C. Here AC side is present, but side AB is not present. Means this AB means the shadow of AB is 0. Means the projection of AB becomes here 0, but the projection of AC is BC. So we will consider here third case. Let us see what happens in this third situation when this angle B is right angle B. Angle B is right angle. Here, once again, find the projection of AB and AC in the similar way. The projection of AB on BC, the projection of AB on BC, it is equal to 0 because AB is vertical to that BC, means it is perpendicular to BC, so it is equal to 0. And now projection of AC on BC, that we have to find. Projection of AC on BC, that is equal to A, that is equal to A here. So let us start with these RHS. Therefore, B cos C plus C cos B, that is equal to, what is B cos C? This B cos C is nothing but the projection of side B cos C is nothing but the projection of AC on BC. B cos C is nothing but the projection of AC on BC plus, what is C cos B? projection of AC on BC. Now this is nothing but the projection of AB on BC. So it is equal to, what is projection of AC on BC? Projection of AC on BC is nothing but A. And what is the projection of AB on BC? It is 0. So it will become A plus 0, that is equal to A. Therefore B cos C plus C cos B is equal to A. We can write in reverse way as A is equal to B cos C plus C cos B. So this is the third part of the same result. A equal to B cos C plus C cos B, that is first. Now we can write, similarly we can prove the remaining two results by considering different angles as acute angle, obtuse angle and right angle. Okay, so this is the way to prove projection rule.
Proof of cosine rule using projection rule.
Prove the cosine rule using projection rule. Okay, we are using projection rule and we will prove now cosine rule. Here, what we know that, since we know that the projection rule for triangle ABC, A is equal to B cos C plus C cos B. While writing this C angle should be in capital letters and the sides should be in small letters. Also, B is equal to C cos A plus A cos C, and small c is equal to A cos B plus B cos A. Let us try to prove the first cosine result. What is that? Here we have taken this. Now, here to prove that A square is equal to B square plus C square minus y is BC cos A. This result we will prove. For that, we have now A and we have to prove this A square. So, multiply this first equation. Let us give the numbers to these equations. This is our first equation. So, multiply this first equation by A so that we get left hand side, that is A square. So, multiply equation 1 by A, we get. Multiplying first equation by A, we get. If you multiply this by A, then A into A is equal to A into B cos C plus C cos B. So it is equal to A square, and it is equal to AB cos C plus AC cos B. Okay. Similarly, we get B square. How we get B square here? Multiplying equation second by B and multiplying equations third by C. So let us do that. Multiplying equation by A, we get. Similarly, equation 2 by B and equation 3 by C. Here we get B square is equal to, I will write directly here, B square is equal to BC cos A plus BA cos C, and last one multiply this by C square, we get by C, we get C square equal to CA cos B plus CB cos A. So we get A square, B square and C square from projection rules. These are projection rules. We are multiplying this by A, this by B and this by C. Let us take the left hand side. That is to prove that A square minus B square minus C square equal to, you can keep this negative sign here, that is minus 2 BC cos A. Means simplifying this, we have to obtain this one. So this will be proved. So LHS of this first, therefore LHS of equation 1, that is A square minus B square minus C square. So it is equal. A square is this, that is AB cos C plus AC cos B minus B square, means negative of this, that is minus BC cos A minus BA cos C or AB cos C. Once again minus C square, that is minus CA cos B and minus CB cos A. So just separate those, which will get cancelled. Here AB cos C and AB cos C, these two results will get cancelled. Then AC cos B and this CA cos B. One is positive, second one is negative. So both get cancelled. Remains these two. Here BC cos A, this is also BC cos A, but with both negative signs. So we get here it has minus 2 times BC cos A, which is the RHS of first. So this is our cosine rule. Or you can take the addition of B square, C square, and with minus 2 BC cos A you will get A square also. Okay. Let us do the second part of this cosine rule. Is in that way. Here, what is the second part? That is to prove that B square is equal to C square plus A square minus twice CA cos B. Consider this RHS. So RHS is equal to C square plus A square. What is C square? C square is nothing but CA cos B plus CA cos B plus CB cos A plus, what is A square? A square is this AB cos C plus AC cos B minus twice CA cos B minus twice CA cos B. CA cos B and here CA cos B get cancelled with each other. So remains only CB cos A and AB cos A. CB cos A plus AB cos A. This is the second way to prove cosine rule using the same results. So can we take common B from both? Yes, taking B in bracket remains C cos A plus A cos C, and it is nothing but B into this is again by projection rule B, so it is equal to B square, that is LHS. RHS to LHS. This is also the another way to prove cosine rule. Okay, so it is very simple. Just you have to remember, in projection rule we have the values of a, b, c, and in cosine rules we have a square, b square, c square. So whatever combination you are taking, just multiply these rules by the respective those values, either a, b or c, and just take that addition or subtraction, you will get the second side. This is the way to prove cosine rule from using projection rule. Okay, let us.
Example number 1 on projection rule.
So first step, LHS is equal to, once again I am writing that, a plus b into cos c plus b plus c into cos a plus c plus a into cos b, and it is equal. Now multiply this, we get a cos c plus b cos c, plus we get b cos a plus c cos a plus c cos b into a cos b. So that we get here 6 terms. Now just make the proper pairs. Here a cos c is given, a cos c. Now find c cos a. Where is c cos a? Here. So we get c cos a as second. Now third term is this, that is b cos c. Now here is b cos c, so find c cos b. Where is c cos b? Here is c cos b plus c cos b. Now remains 2 terms, because this a cos c and c cos a we have taken together. Then this one is b cos c and c cos b. Now remains b cos a, this one, and this a cos b. So you get b cos a plus a cos b. Now we have these 3 pairs. If you observe carefully, then a cos c plus c cos a is nothing but the b by projection rule. B cos c plus c cos b is nothing but a, and b cos a plus a cos b is nothing but c. So rearranging, we get a plus b plus c, that is equal to our RHS. So this one is very simple to prove.
Example number 2 on projection rule.
And prove this example by using only cosine rule or using projection and cosine, both rules at a time. Let us first prove the same example with only cosine rule. Here LHS is as it is. So it is equal to 2 times in bracket BC. What is cos A? Cos A is nothing but B square plus C square minus A square upon twice BC plus CA into what is cos B? Cos B is nothing but C square plus A square minus B square upon twice CA. Next, plus AB into cos C is A square plus B square minus C square upon twice AB. We have used cosine rules 3 times on the position of this cos A, cos B and cos C. Okay. Now this BC will cancel with this BC, CA will cancel, AB will cancel. Now remains at the denominator only 2 in each term. So denominator is common, so we can take the addition of numerators. So it is equal to 2 in bracket B square plus C square minus A square. There is plus, so no changing signs. C square plus A square minus B square. Last, plus A square plus B square minus C square, whole divided by only 2, and that will be cancelled with this. That is already given to the left. So it is equal to, now b square, this minus b square get cancelled, c square, this minus c square get cancelled, minus a square plus a square get cancelled, remains here c square plus a square plus b square. So we can write it as a square plus b square plus c square, that is equal to the RHS. Okay, so this one is very easy to prove using only cosine rule. Okay, now let us try to prove the same result using projection and cosine rule. For that, our LHS is given. If we observe these two first two terms, then from these two terms, what is common? Here C is common. In both terms, C is given. So from LHS, take common C from these two terms. So 2 in bracket C in bracket, we get here B cos A plus A cos B. Is it okay? From these two terms we have taken C common, so remains B cos A and A cos B. The third term is as it is, that is AB cos C. This is our first step of LHS. Now, if you observe this bracket, then by projection rule, here B and A are given, so this will be equal to C. So you get 2 in bracket C into C plus AB cos C. That is equal to 2 in bracket C square plus. Now use here cosine rule. Cosine rule is for cos C it is A square plus B square minus C square upon twice AB. Once again here AB get cancelled. So it is equal to 2 in bracket, making denominator equal here in the bracket, we get 2C square plus A square plus B square minus C square upon only 2. These 2 get cancelled to this 2. Here 2C square minus C square is C square, so remains A square plus B square plus C square, that is our RHS. So this is the way to prove this result using projection rule and cosine rule. So this is the way to prove such results using cosine and projection rules. There are some examples which need sine rule, cosine rule and projection rule. So those are very much important in solving triangle and proving such results related to the triangle ABC. Okay, we will stop here.